All right, so we talked about preserving evidence and collecting the evidence. Now we have to talk about what do we do with it once we get it from there. So we're going to talk about imaging, cloning, and hash verification and some of the processes that we use. The rule of best evidence is a common law rule. It goes back way back in the day, what, 1745 according to what I found. The rule of best evidence is the original evidence is always best. But that doesn't always work with computer forensics because of the fragile nature of evidence, digital evidence. So you have to understand that we can't be working off the original hard drives. We can't be working off the original files because what? We'll change those files. We can overwrite them. Well, then the best evidence rule states that a copy, an exact duplicate, can be used to process and use best evidence. So be careful with the best evidence things, because there's been many examiners that, well, I can't do this because it's not best evidence, it's not the original. Well, if all you have is a copy, that's all you have. And it's fairly admissible in court, and we have never had an issue with it. So we make it a copy, we verify that a copy is a bit to work off, and we take that copy and use that in there. And it doesn't matter if you can say, listen, through a hash verification, whether it be MD5 or 256, if you can say that this is an exact duplicate, that's fine. It's nothing more different than a clone of a sheep is an exact DNA match of that sheep. You could do an autopsy on both of them, you're going to find the same things. It's a similar approach. Let's acquire some evidence. One of the things we have to worry about is inadvertent destruction of evidence. Whoops, the old whoops factor. Hey, was your right blocker in place? Did you accidentally hit delete? Did you mess around with the keyboard? Hey, if you did something, document it. All right, it's the old adage. You're going to get in trouble for lying more than you would if you just documented what you did. Almost anything can destroy evidence, but you don't want to rush through these things. You want to take your time. You want to make sure that your connections are correct. You want to make sure that you have everything, all your ducks in a row. Rushing through this, when I rush through things, is where I've made my mistakes. And listen, if you, like I said, be honest if you make a mistake. If you preserve the original evidence, if something happens to your image, you can always get the original evidence back. It was preserved. We can verify that it was preserved and it's still in its original state. We can make another copy of it if we have to.
The first FTK imager function that we'll cover is imaging. To start off with imaging, two ways to get that started. There's a icon on the toolbar, create disk image. You can also access that same function from the file menu, create disk image. So one of those two ways will start our process. Once we do that, we see we're presented with the various types of items that we can create images from. Physical drive, logical drive, an image file, contents of a folder, and a Furnico device, so that if you have one of those hardware items for multiple CDs, that you can tie in Imager's functionality with that. For the demonstration here, we'll choose physical drive, which is what you'll do a lot of the time. Click my next button, and then Imager will present you with all the physical drives that it recognizes. And of course, this will vary depending on your setup. Normally, drive 0 will be your boot drive. Take note that it is a 0-based numbering system. Also note that your code meter, if you have your dongle in for FTK, that also has some storage capacity and will count as a drive, both physical and logical for that matter. For our example, we have a flash drive in here, and we'll use that, SanDisk Cruiser Micro. I choose my drive and click Finish. Then I can proceed with my imaging. Have to provide a little bit of info first. First thing I do is I'll click my Add button. And then I see the various image formats that Imager supports. And by default, we've gone to the raw DD, which is an uncompressed image, the smart image file, E01, and then AFF. For our example here, let's create an AFF advanced forensic format, kind of an open source, if you will, or non-vendor specific image format. We'll choose that. Click Next. And here you have the opportunity to fill in case information similar to what you would see for an S01 file, a smart image file, or an E01 file. So you'll fill in the appropriate information here and whatever notes and that sort of thing that you might want to enter here. And I'll just place a note in here created from thumb drive. Go to my next screen, and now I make two choices. First of all, I choose where I want to create my image file, and secondly, what I want to call that. So I'll browse to a location, and on my desktop I'll create a folder that I'll use, and I'll just simply call this ACE Prep. And let's say that's where I want my information to go. That's where I want my image to be created. And then secondly, I have to come up with a name for it, and I'll call this whatever I'd like. In this case, I'll just call this Prep. Now notice that the image will automatically be appended with the file extension, so I don't have to supply that. That's why it says excluding the extension here. Then, based on the size of this, I have other choices. My image size, if I want to break this into pieces, maybe for anticipating the idea of storing it over a series of CDs or DVDs, I could break it into a specific size. Secondly, you have the option with this format along with S01 and E01 to choose a compression level. Imager defaults to level 6. The other thing that you can do is you also have the option of supplying a password to encrypt the image file. And if you do that, you'll check the box. Let's actually do that just to show you how that works. I'll check the box for that. So I've made my choices, where my file will be created, what I'm going to call it. I'll click Finish. And now, since I had the option checked to provide a password, it's asking me what my password will be. So I'll just simply use a very short password, just ACE, for my password. Confirm that, and now I'm ready to proceed. So now at this point, I have all the information I need to create my image from my target. What Imager also allows you to do at this point is to create a second image file. So let's suppose for a moment I want to do that. I would just repeat the same couple of steps that I just did by clicking Add, choosing my new image format. So let's suppose I wanted to create a smart image file this time, and then I would proceed and go through the same steps that I just did. And the end result is, from one source, I can simultaneously create two different image files, perhaps saving time in doing so. Anyway, I'm going to cancel out of that part. I don't want to actually create a second image file now. So now I'm back to my original AFF image file. And note that by default, Imager has the checkbox for verify images after they're created, which means that after the image is created, there'll be a second verification pass just to make sure that my image file was accurately created. So now I'll click my Start button, and the imaging begins. My imaging process is now finished, and I now have the drive verification results window, and here I can see the name of my image file, the number of sectors, and then the hash values, both MD5 and SHA-1. Note also that as you highlight each field, down below Imager tells you what that is. In this case, I have my computed hash, which was the verification, the report hash, which was the one that was actually calculated during the acquisition process, and that we will see in our verification file as well. Note also there's a bad sector list area in case there were bad sectors encountered. So now I'll close this, and there's a button here to get to your image summary information, which you can display this way. Up above you should see whatever information you supplied when you created the image file. And below we can see specific information supplied by Imager. The drive geometry, for one thing, and some other information as well. Now, the same information we can look at by actually looking at the file that was created. So I'll close this, and I'll downsize Imager just for a minute. And here is the folder in which I created my image file. And within that folder will be the accompanying text file that has the image summary information. So here's the same information that we saw within Imager, along with the drive geometry. Noting here in the drive geometry, it gives you the number of sectors specifically. Also, we have our hash values, both MD5 and SHA-1 checksums. And this is something that we can add later on to FTK if indeed we generate a report based on the contents of this image. We'll see how we can add that into a bookmark in FTK and make that very nice and neat to document.
Well, since we don't have hardware write blockers and we can't send them all out to you guys, and they're rather expensive to buy, we're going to be using some write blocking software. One of the ones that we can use is SafeBlock. They have a free trial. You can go to their website and download it, and it gives you an opportunity to block a partition or a drive or a files. And a lot of people use it. It's not as good as a hardware blocker, but it still is operational and functional. And here's another one. It's a USB write blocker off of SourceForge. Open source is okay, but you got to make sure you test and verify that it's working. How do you do that? Go back to our verification chat and make sure you test that is this software write blocker doing what it's supposed to be doing, and document that. Hey, if it's not written down, it didn't happen. Here's your assignments. Week 2, Lab 2. You got to answer one question and respond to 2 of your classmates' questions. And I want a 1-page paper on how to use a write blocker.